Now let me bring the slides. So we talked about some introduction to some common mathematical equations and how they are used to predict future values. And we also introduced the idea about the trend lines and the trend line tools. We are going to cover today regression, so different aspects of regression. Now, what is regression analysis? So let's read the slide. Regression analysis.
Regression analysis is a tool for building mathematical and statistical models that characterize relationships between a dependent, ratio, variable and one or more independent, or explanatory variables, ratio or categorical, all of which are numerical. Simple linear regression involves a single independent variable. Multiple regression involves two or more independent variables.
Right. So although here it is telling that the statistical model that characterize relationships between a dependent variable and one or more independent variable. And you can see it, this term was presenting with like ratio or explanatory variable, but it's very handy. You can say dependent variable and independent variable. That's the easiest term to use. When we are dealing with one independent variable and one dependent variable, in that scenario will be termed as a linear regression. But if there is multiple independent variables, so multiple regression involves two or more independent variables. So when an independent variable is more than one, we'll call it as a multiple regression. So that's the general concept. In this slide, you can see it is presenting different kinds of relationship. Let me make it a little bigger so that it will be easier for you to, and even for me. You can see here different trends. One is linear, second one is non-linear, and no relation. So the third one, data is so scattered that the system couldn't find any pattern, whether it is polynomial, exponential, logarithmic, or linear. But you can see here, this one is linear, this one is non-linear. Now let's lead the slide.
Finds a linear relationship between one independent variable x and one dependent variable y. First, prepare a scatter chart to verify the data has a linear trend. Use alternative approaches if the data is not linear.
Right. So when you are trying to find a regression, even you can fit this line that was part of our last week's lecture. We talked about some trend lines, and I showed you how to find the trend line from Microsoft Excel. So that's one of the part, so that you will understand the pattern or alternative approach if data is not linear. This will help you. That's again data visualization to choose a method. All right. So now in this slide, you can see two screenshots. One is an Excel file and another one is a graph that created, excuse me, created with home market value data set. So here there are two variables x and y, and x is square footage that represent the size of a home, and y representing the market value, right? So say we know the size of the home, then we have some previous values so that we can estimate the value, we can estimate or predict the value of a certain home by using regression. So let me go back to an Excel file, and you can see this is the data. All right. And in this data, you can see there are three items here. House age, square feet, and market value. So let's create a scatter chart with those two values, right? And insert, and let me go for scatter chart, and let me find the chart type, and I'm going to choose this one. All right. Now fix the scale at the bottom format axis. I'm trying to make it as your slide, right? According to your slide. So you can see the scale is started from 1,400 square feet to 2,600, and here 60,000, right? So let me fix the scale so that it will look alike. What is that? I should select that and say format, and we started from 1,200. And this value will be starting from 60. So 60,000. Right, you can see now it's pretty much look alike your slide, the figure given in the slide. Now, if I fit this line, and if I select trend line, it is automatically choosing the linear, right? So let me select more options, and we know how to choose that. It's by default. Now you can see here there are a couple of items here. So display equations and R square value. Now we introduced the value of R square in our last week's lecture. If the value of R square close to 1, that represents a best fit. If it is close to 0, that means that represents the worst fit, not the best fit, right? So here we can see R square is pretty much a little above than 5. So we can say it is a good fit, although we can see a bunch of outlier values, right? Those are really far from this line, right? But still, this is a good fit. All right. So let's go back to the slide. Now, the value of x and y, right? And I also added a linear equation here. You can see, I'm not sure if you can see, maybe I can make it a little bigger so that it will be easier for you to have a look. How do I make it? Okay, Control Z. I can go, let me make it say 14. All right, now we can see. So you can see the value of x and y is the market value. Now, if we know the size of a home and we can put this x here, value of x, then we'll get the price, right? So let me go back again to the next slide. And you can see this market value equal to A plus B square feet. That means the unknown market value will be the unknown, and square feet is our known value. That's the home size. And here you can see this example. They draw two lines here. Line is A is clearly a better fit to the data. Obviously line A. And if you look at this line B, that's not the best fit. It's touching only 1, 2, and here a couple of points. But here you can see this line A, it passed through the most lines. Now, how do you choose that? You know the slope. I'm not sure. Just remember the term slope. Slope controls the direction of the line, and slope is a vital information to fit a line with a certain set of data. So let's move to next slide. And they're giving some example here by following this equation. And the estimated market value of a home with 2,200 square feet. And if you calculate there, and you can see this is the value, and they put the value of X here. Now, let's read the summary.
The regression model explains variation in market value due to size of the home. It provides better estimates of market value than simply using the average.
Right. So it means, say, we have some historical data, and we have those market value, right? And we have this square feet or the home size. Now, if you say create an average, means there are, say, 41 rows there. We added all them and divided by 41. And same way we can do the market value. And we can say this is the best fit of the value. But probably not, that's not the best fit. And you can see here, there is no like 2,200 here by putting. So we are actually predict some value by calculating some historical data or existing data. All right, I hope it makes sense to you. All right, so certainly average may not give you a better solution. Rather, if you use a regression equation to predict a value, that is a better solution. All right. Good. Now, this slide is talking about, let me show you an easy thing. This equation looks very simple, right? And here, y equal to, go back to this slide, and I believe, see, y equal to ax plus b, right? Or b plus ax, whatever. So y is unknown here. So this is a very simple equation for regression. And it's a linear equation, more precisely. Now, if we go back to this slide, you can see it has a little different form of the equation. And don't worry too much because there is a slide, so I'm explaining you, but this symbol is called epsilon, and epsilon represents the error. Say we are predicting a value, right? And there obviously some error there because it's not 100% correct, but it's a good value as a prediction. And that's how we do so many things nowadays. We predict, and that predict is really makes sense in most cases. So this is error. And if you consider this error is 0, then it's literally coming to that simple equation y equal to ax plus b, right? And here in 8.2 is the same thing. Now, if you read here xi be the value of the independent variable, right? Now, what is independent variable? That's the price. And what is dependent variable? Is the home size. So we know the home size and it's a known value and we are trying to unknown an independent variable. If ith observation, when the value of the independent variable is x, then y is b0 plus b1 x1 is the estimated value of y for x. All right. Now, in this equation, you can see EI that's represent the error, amount of error. Now, what is the amount of error? If you see a price that's representing a dot, right? And how far the dot is from this regression line, and it is linear. So certainly this E1, you can see here the distance and slope, and E2 distance and slope is different. And that's how it's calculates the error, and it's called residuals. Now let's read the slide, and I'm going to explain you residual with some Excel formula. So you don't need to remember those figure or the equations. There is a precise formula for that.
Residuals are the observed errors associated with estimating the value of the dependent variable using the regression line.
Right. So remember it, residuals are observed errors. That's is key so that you know what is residual. Residual is an observed error. Now you can see here, there are two formulas are showing here, intercept and slope. Now, if I go calculate those things, it will be too much for you. You can read the text always, and I put there is an example and page number 322. Let me bring this. This number 322, and you can see here this example talking about those two formulas, right? So let's um, go back to the Excel file, and we are going to explain you two values there, intercept and slope. Now, what are those intercept and slope? So let's go back here, and you can follow. I'm going to like make this, I will generate the same thing that your book is explaining. So it will be very useful for you. So let's see. First is intercept. Intercept, right? And let's see here. Intercept, right? So let's hit here. Intercept. CINTERCEPT, insert. Intercept. And if I go here, and our known is C4, C45, and B4 and B45. And let's see what happened here. And you can see this intercept value is this. Now slope. Slope equal to slope here, and let's known y and excess values. So from the graph, we know C, C4, C45, and B4, and C, there is a value that's called slope. And if I go back here in this slide, and here in this direction, you can see this slope is actually measured in angle, right? So here we are using these two formulas to calculate the value of intercept and the value of slope. And if I go back here, you can see this is the range, right? If I click here, you see this is B4 to 45 and C4 to 45. And you can see this formula. And here you can see this slope. Thus, the value of slope is 35. Now you can see here the trend, and that trend actually calculating here. I can show you in the same example. This is the trend. And this trend literally calculating the value. So this is the square feet. You can see this 1755. This value is a square feet of a home, right? And using the trend function, you may estimate the market value of a home or house with 1750 square feet with the formula trend. So trend actually doing a regression analysis. So if I go put trend or estimated price, you can write it down, estimated price or home price, whatever. And let's put 0 and TREND, trend, and known-wise C4, C45, now known excess, right? It's B4, B45, and our home size is 1750 square feet. If I go here, you can see this is the estimated price. And at the same time, I'm showing you in your book example so that you can read and connect both together. Now let's go back to the slide so that I can explain you. And you can see here the example we saw in earlier slide here. The final formula is y b0 plus b1 x. And here they use the same formula, slope, and slope is B1 is 35.036. And you calculated with this, and we did that already in Excel file. The value of intercept, that's B0, is 32,673. And you can calculate this intercept with this formula. Now estimate y, where the value of x is 1750, and x is an independent variable, right? Because we know already the size of the home, and different home has a different size, and we are predicting the value of y. And if we apply this formula, you will find this by calculation, and it is same as this trained formula in Excel. So clear? How do you fit the linear regression in Excel? That's three formula: slope, intercept, and trend. And it has precisely mentioned that first value of y is then known value of x, known value of y and known value of x. That's how we are going to calculate the intercept and slope. Then you will apply this trend to fit it for linear regression. All right, any question? So we learned something new with these three different Excel equations to fit a regression model to predict price. Any question? All right. So I always sometimes do some fun with my students. Like if there is no question means two meaning. Excuse me. You understand everything or you didn't understand anything at all. So I'm a positive person and you're a bright student. I know you understand. All right, so let's move to next portion of our lecture. So simple linear regression in Excel. So we are going to use this linear regression using data analysis tool. And we activated our data analysis tool pack probably in week 4 or something, right? If you forget, you can go back in week 4 and you can activate your data tool pack for data analysis in Excel. All right. Okay, let me have some water. All right. So it's pretty simple, and we all know how to use this data analysis tool pack. So here, input Y range with header, input X range with header, check label box. So check label box so that it will exclude, okay? Excel output a table with many useful regression statistics. So how do you generate? And if we use this data analysis tool pack, literally we are getting a nice output like this. So instead of manually calculated those and feed the trend line, you can generate this kind of statistics with a value from data analysis tool pack. Excuse me. So let's go to data again, okay? So those are those three values. Now I'm going here in data menu, and I'm clicking data analysis toolpack. And from this data analysis toolpack, we used histogram many times, I believe. So let's choose regression and click here. OK. Now you can see here, I already choose those ranges from C and B for Y and X level. But if you choose a label, then make sure you check this so that it exclude the label. At the same time, you can see here new worksheet, new workbooks, new workbook, or you can even keep the output within this sheet, Excel sheet with a certain location. So I found it is always good go for a new worksheet, okay? And let me just click here. And you'll see a nice statistics there. And we are using the same data, right? We are using the same data. And why I'm telling it, some of the values are familiar to us. And let me, if I can actually make those little bigger so that you can see well. Okay. Can you remember the value of R squared? We found 5.3 in the very starting when we were calculating and which slide is this one? Probably at the very top somewhere. No, even top, I guess. Okay, let me go to the Excel file. That should be easier for us. So we can see here the value of R square is 0.5347. We calculated it manually from different tool. But when you use data tool pack, and you can see this value we generate same value we generated using data analysis tool. All right. And you can see R square, adjusted R square. So it is even giving us a detailed result, or because it's a data analysis tool, so it uses data in different ways and show us the result. All right. So let's go here. Actually, we generated this one. Go back to the slide. And you can see this, we generated all those different values and regression analysis results or statistics here. All right. See, this value is known to you, 35, slope and intercept. You can see all the same value that we generated manually also can be generated using data analysis tools. All right. Now, multiple R square, adjusted R square, and standard error. If you go back to this slide, and you can see this is standard error, right? Okay, sorry, standard error. Coefficients, t-stat, p-values, those are those errors. Now, how do you interpret a regression and use those data? That's quite a bit of reading, and you have to use your textbook to understand all those. So you can see here all those values presented in this slide, whatever is multiple R, R square, adjusted R square, standard error, everything you will find here in this site, right? Multiple R square, adjusted adjusted R square, right? Standard error observations. And we have 42 observations in the slide. So all different statistics you can generate with a single click. That's data and data analysis tool. And you have to choose regression, and you have to choose the right columns and cells, and it will give you the regression statistics. All right. And the item I just showed you is well explained with lot more text here. You can see in your textbook. So please try to find your book and try to read this chapter, because there are a lot of technical terms you might forget quickly if you don't read yourself. Okay. Let's go back to next slide. We are in slide number 22. So let's go in 23. So the items is showing here, all are available to the to this generated Excel sheet using regression analysis tool. Now, ANOVA, right? Regression as analysis of variance. So there are few statistical terms we always deal with: standard deviation, relative error, and variance. So when you do a regression as an analysis of variance, and that's termed as ANOVA, right? So let's read this few lines.
ANOVA conducts an F test to determine whether variation in Y is due to varying levels of X. ANOVA is used to test for significance of regression.
Okay, so that's significance of regression. And the analysis we generated here, you can see there is a column ANOVA. There is a heading ANOVA, and you can see this regression, residual, and total columns. And there are different kind of measures given here. And the terms mentioned here, this p-value, you can see this p-value is the significance of F, and it's called the F test. So ANOVA conducts an F test to determine whether variation in Y is due to a varying levels of X and how significant it is. And you can see here, these p-values are given here, right? And you can see this is really low, and this one even lower, because there is a e to the power minus 0.8, means minus 8. So now how do we interpret? That's the significant question here. Now, to understand all those, I want you to read all those different texts, right? And whether if it is good or bad, or how do you explain? And I'm going to give you a project on the regression so that you can write your report, and that report mainly on the regression analysis. And you can see here, this is standard error. So all those definitions you need to read, okay? Let me go back to the slide. Now here, interpreting significance of regression. If S0, that's it's a ratio of B1 equal to 0, home size is not a significant variable, right? So of course, if the home size is 0, then there is no home, right? So there is no significance of it. If H1 or B1 is not 0, home size is a significant variable, of course, because the size of the home is one of the key variable that's control the home price. So you understand this, how it is interpreted, the significance of a variable. Now, reject is 0. The slope is not equal to 0. Using a linear relationship, home size is a significant variable in explaining variation in the market value. So of course, the size or home size is a significant variable in predicting home price. Now, an alternate method for testing whether a slope or intercept is 0 is to use a t-test. And this is the formula for t-test, right? Now, you don't need to remember this formula if you use a regression analysis tool that built in Excel. And if you go back to this data, you'll already find this t-stat here, right? Now you have to read the book and find those different values of the interpretation of different values and errors. And Excel provides a p-value for test on the slope and intercept. Now, interpreting hypothesis test for regression coefficient. Again, regression coefficient, and use p-values to draw conclusion. Neither coefficient is statistically equal to 0. So if I go back this generated statistics, see, none of them is equal to 0. There is some sort of value, although small, but it is not 0. So there is a significance. All right. I believe we should take a break. All right. Let's take a break for around 20 minutes. Now it is 6:20. Take a break of 20 minutes and we'll be back at 6:40. Okay. But before leaving the classroom, do you have any question? So I introduce you the Excel regression, the how to calculate it manually. Then I introduced you the data analysis tool, how to use regression analysis and generate those different kind of statistics. So any question on that? I'm going to provide you the data right after my lecture and slides. Of course, slide has posted already because today is the second day we are covering chapter 8. So that's you should have that slide already. If not, I'm going to post it again. Any question?
Okay. Sorry, Professor, can you hear me?
Yes, I can. Inaku, I can hear you.
Yeah, I actually emailed you a couple of times. You haven't replied to them. But question on this. So you said to read the textbook to understand the Excel practical part, that the textbook would help us. Guess you said chapter 8 of the textbook.
Did I send chapter 8? Probably not, I guess.
Yes.
I don't believe I sent chapter 8. I don't believe I provided any PDF because those materials are copyrighted. I cannot provide those with this course shell.
No, you said if we should do our best to get the textbook.
Yeah. So I'll encourage you to have the textbook, and I'll encourage you to read that for understanding all those different parameters, right?
Okay.
So say in a single click, we generate so much data here. You can see in this shared file. Now, how we measure the significance or accuracy or the significance of errors. Now I want you to read the text. That's explained here. You see so much text here. So if you read it, then it will make more sense to you on the top of the lecture that I'm giving during this class.
Yeah,
Is that clear, Inaku?
Yeah, which is chapter 8, which was what I was referring to.
Yes, chapter 8 I'm referring to.
Okay.
Yeah, you are correct.
Okay.
Good.
Yeah, thank you.
All right, thank you. Any other question? All right, so let's come back and we'll start the second part of the lecture soon. All right, thank you. All right, everyone. Let's wait a couple of minutes and we'll start soon, okay?
Hello, Professor.
Hey, Ishar, go ahead. What is your question?
Yeah, Professor, I haven't got any group yet because I'm not in contact with any class members. It's online
Yeah,
class.
just put your name any of the group. If you see anywhere just 2%, just put your name.
Okay, okay, Professor. There's
Yeah,
one. I
yeah,
can see one person in one group.
yeah, sure. If you see anywhere 2% or 1%, put your name there.
Okay, Professor. Thank you.
Okay, thank you. No problem. All right. So hello everyone again. Let's start our second session about today's lecture. All right, let's go on the top and we left here. Testing hypothesis coefficient here, confidence interval. So let's talk about confidence interval and what is confidence interval and how the significance of confidence interval. So let's read the content of this slide.
Confidence intervals, lower 95% and upper 95% values in the output, provide information about the unknown values of the true regression coefficients, accounting for sampling error. We may also use confidence intervals to test hypotheses about the regression coefficients.
Right.
To test the hypotheses.
Right. So the hypothesis, because we are predicting a value, that's why it is calling hypothesis. That's one of the key understanding from this slide. And confidence interval, that's provide information about the unknown values of the true regression coefficients, accounting for sampling error, right? So two things, unknown values and unknown values of the true regression coefficients and accounting for sampling error. Now, let's explain it through the formula and example. That's will make more sense for you. And here you can see there are two cases, H0 that beta 1 equal to B1 and H1 beta 1 not equal to B1. And check whether B1 falls with the confidence interval. So what is the confidence interval? Lower 95% and upper 95%. So the confidence interval for the slope, it does reject the null hypothesis, right? Now, what does it mean? Let's go to this example in the next slide. So for home market value, a 95% confidence interval for the intercept is 14 and 50, and for the slope 24, 59, and 45, 48. 45, 48. Now, if we use this interval, right? Although the estimated that a house with 1,750 square feet has a market value of $93,000, almost 94, right? And we applied this and we excuse me, found this value from the analysis tool and manually applying the regression formula in Excel. If the true population parameters are at the extremes of the confidence interval, the estimated value might be as low as 57,000 or high as 130K. Now, the real value, the estimated value is 93. But if we have some outlier values, or the confidence interval, and you see here there are two values, that's intercept and slope, and we when we calculated this 93,000, the intercept was the slope was 35 and intercept was 32,000 or something. Now, if you change those values and apply that equation, then the value would be 57K or 130K, right? And this is the formula for residual actual Y value minus predicted Y value. Standard residual is residual divided by standard deviation. And standard deviation, you know, like is the certain value with minus the average value, right? The rule of thumb is standard residuals outside of plus minus 2 or plus minus 3 are potential outliers. And here, see, these values are actually outlier values or a special case. So rule of thumb, standard residuals outside of plus minus 2 or plus minus 3 are potential outliers. So if you see a standard residual value, and if you add plus 2 or minus 2 or 3, that is a outlier. And Excel provides a table and a plot for residuals. So let's go back to this. Excuse me. Let's go back to this Excel again, right? So we generate this, and we generate using these, and let's click on these residual plots. And if you click here, oh, what it is saying? Should we see? Submit. And we choose these residual plots. And you see, we found these residual plots here. And if I make it bigger, and if you go back here, you can see this is a outlier value, right? That's far from this the line that we fit with that data. So let's go back here. And if you go here, you can see this line is fit with the best fit with this linear regression. And if I go here, that's 7, I guess. And it is certainly an outlier data, right? Because see, this price is like is not with the maximum data. Say you live in a city and that city has a home, and most home has the like kind of say million or 500K, 500K or 300K. But if something is like say 30 million, then it's an outlier value, right? And we do not have that data to predict that kind of value. And it's outside of the range. And the rule of thumb is telling here plus minus 2 or plus minus 3. So while generating this like the home price, you can also generate this graph, and you can find the now checking assumptions. Now we're still talking about how do we, and if you go back to your textbook, you find here checking assumptions, and all those texts are nicely explained with examples. But we are going to cover it with the slide again, in the slide 2. So there are a few terms here: linearity, normality errors, oh my goodness, I'm having difficulty to pronounce this.
Homoscedasticity.
Okay, homoscedasticity, all right, and independence of errors. So let's read this slide.
Linear writing. Examine scatter diagram, should appear linear. Examine residual plot, should appear random. Normality of errors. View a histogram of standard residuals. Regression is robust to departures from normality. Homoscedasticity, variation about the regression line is constant. Examine the residual plot. Independence of errors, successive observations should not be related. This is important when the independent variable is time.
Right. So you can see, I believe the linearity is making more sense to you. All other different errors. When you provide the Excel file, please generate those graphs. And after generating those graphs, you can read the text so that you can connect those information and you will get the ability to interpret a regression model. Okay. Here. And you can see like generate other graphs as well, line fit plots. And if you go here, it will give you a line fit plots. You can change those parameters, like how would be the line, how would be the width of the line, and you can see this value is certainly an outlier. Okay. All right, so let's move to checking regression assumption. And we already talked about this linearity model. And this graph is obviously familiar to you. And I just show you the square feet residual plot, and it is an outlier here. Now you can also draw a standard residuals. That's an error, right? Normality errors. Residual histogram appears slightly skewed, but not a serious departure. So you can see here it is little bit skewed at the right, but those numbers are really small. See here the main concentration here at the middle, and that means those two big diagrams has more data, and those data lies close to that fit of line or regression line. All right.
Homoscedasticity, residual plot shows no serious difference in the spread of the data for different x values.
Right. So see again, like maximum data lies on this X line, other than couple of outliers values. And this one is really far, but this one is kind of okay. Like, but this one is really a typical outlier. All right. Let's independence of errors.
Independence of errors, because the data is cross-sectional, we can assume this assumption holds.
You have to read book to understand all those explanation, right? And we are giving emphasis on linear regression. So I believe like this out of those linearity, it makes most sense to you. And the other errors or interpretation, you need to read a little bit by looking at generating those graphs, plots, and you need to read the book. Okay. Now, next item is multiple linear regression. So when we introduced this class, we told like there are two kinds of regression. If there is a multiple independent variable, then it's called the multiple linear regression, right?
A linear regression model with more than one independent variable is called a multiple linear regression model.
And you can see this equation is in the first case, we have y equal to beta plus b1x. Now it's extended with x1, x2, xk. So those are those different independent variables. So that's why it's a multiple regression. And you can see this error. Error is a component that is called epsilon, and it's if error is big, then the significance is less. If error is less, then significant is more, right? Means more correct regression value or predicted value it generates. Where y is the independent variable, and we know x1 to xk are the independent explanatory variables. Beta 1 is the intercept, beta 0. Beta 1 to k are the regression coefficients for the independent variable, and epsilon is the error term. So this equation is an extension of a linear regression. It's again explaining the same thing, generalizing just the difference between here and in this equation is by ignoring the 0. And let's read this part.
The partial regression coefficients represent the expected change in the dependent variable when the associated independent variable is increased by 1 unit while the values of all other independent variables are held constant.
Okay, so and we estimate the regression coefficients called partial regression coefficients. Like, don't worry too much with those lines or equations. You will use data analysis tool or Excel formulas to generate all those calculations and estimations. Now, Excel regression tool.
The independent variables in the spreadsheet must be in contiguous columns. So, you may have to manually move the columns of data around before applying the tool. Key differences. Multiple R and R square are called the multiple correlation coefficient and the coefficient of multiple determination, respectively, in the context of multiple regression. ANOVA tests for significance of the entire model. That is, it computes an F statistic for testing the hypotheses.
Like in linear regression, we saw just beta 1. Now you can see this beta 1 to beta k. H1, at least one BJ is not 0. So because there are multiple independent variables, so at least one should not be 0. Then it will turn as a case of linear, right? If all other 0, or maybe there are 10, then 2 is 0, other 8 is non-zero, then it is still a multiple, or it's called multiple regression. Okay. Now ANOVA.
ANOVA tests for significance of the entire model. That is, it computes an F statistic testing the hypotheses.
Right. So these ANOVA or F statistics is calculated for those multiple variables.
The multiple linear regression output also provides information to test hypotheses about each of the individual regression coefficients. If we reject the null hypothesis that the slope associated with independent variable I is 0, then the independent variable I is significant and improves the ability of the model to better predict.
The independent variable, if we cannot reject is 0, then that independent variable is not significant and probably should not be included in the model. So when you generate these statistics using analysis tool, you'll see you'll see and find the different values of those statistics, and it is talking about those different statistics in case of multiple regression. Now there is a data table here, and I also have the data with me. That's college and universities data. Let me open this. You can see for our previous one, there are only two, I guess. That's the home price, size and price, right? And one of them was dependent and one of them is independent. In this case, you see here, there are multiple columns is here. And graduation rate, top 10%, expenditure per student, acceptance rate, and median of SAT means say SAT, right? It's kind of a IELTS kind of exam to judge a student. All right. And if you apply this regression model, you'll see these. You'll be able to generate those statistics, and it is showing some graduation rate here, right? So graduation rate and SAT, and this is the rate for this. So let's try to do it a graduation rate and SAT. Let's how does it behave with this, right? So you have to go in data, right? And you have to click here. So graduation rate and SAT. So graduation rate is G, excuse me, and it's from 4 to 52, okay? Let's see. So graduation rate is G4, G4, G52. And acceptance rate, right? Oh, SAT is C. C. 52. And let me, so let's click OK. Okay. I understand now. So okay. So you can see here, it's generated a statistics. Now you can pretty much see the same form of the data. And you can see these multiple R, adjusted R, standard error, observation. There are 49 observation in this case, and it's regression, residual, and total. And you can see all those p values, t values, and these upper limit and lower limit values, right? So you can apply the same analysis for multiple regression, multiple linear regression model, and you can generate the same statistics and use to read all those information to interpret that data. Okay. And now again, all those slides is talking about the different cases and how to interpret those data. So it's pretty much the same idea that we discussed in case of linear. Rather, we need to go, let's introduce a new concept that's called overfitting. So overfitting is a problem. Okay, so let's because we're moving in a new idea. So any question on multiple linear regression? So we talked about typical and general linear regression, then multiple independent variable linear regression. So you'll be using same analysis tool, but you have to choose which columns you are going to process the data. Okay. Do you have any question so far? Because overfitting and underfitting two things. And let's talk about overfitting. So we already familiar with outlier. You can see how outlier resides and is far from this regression line or line of fit, right? Let's know about overfitting.
Overfitting means fitting a model too closely to the sample data at the risk of not fitting it well to the population in which we are interested.
In general, why overfitting happen means overfitting could be happen for various reasons. Say imbalanced data, and imbalanced data, repeated data, not having enough data. Those are those reasons this overfitting could happen. Say in your historical home and price data, if a data is repeated or a very few number of data with a similar repeated value or similar value, I rather say, then overfitting would be a case, and overfitting is a very bad idea. And overfitting could create a lot of inconvenience in your business because that's not the true data. That's you have to remember, right? Now, in fitting the crude oil price in example 8.2, we noted that the R square value will increase if the fit higher order polynomial functions to the data. While this might provide a better mathematical fit to the sample data. Doing so, we can make it difficult to explain the phenomena rationally, right? And there is some explanation on the multiple regression case as well.
In multiple regression, if we add too many terms to the model, then the model may not adequately predict other values from the population. Overfitting can be mitigated by using good logic, intuition, theory, and parsimony.
So if you see an overfitting and getting some kind of result, then you have to do some data visualization. You have to try different fitting, which model it should fit. That's how we can remove, you can get rid of overfitting. So just in a nutshell, overfitting is not a real data, and that's risky. And overfitting is actually fail of a model. So you have to be aware about overfitting. All right. Now we have some other regression model here, regression with categorical data. I'm not going to cover it today. So that's all from my side today. And we cover three things, mainly regression analysis, that's linear or simple linear regression, and multiple regression, that is multiple independent variable. And you have to apply, we have to check the trend of data, that what kind of model you should fit for your regression model. Most examples today, we talked about all linear with single variable and multiple variable of linear regression in 2 cases. We calculated those values manually, and we also showed you how to calculate and generate statistics on regression model using data analysis tools. We talked about error, and we also talked about how to interpret that data. So when you interpret the data, you can see different statistics generated by the data analysis tools, but few of them are vital. That's the range, 95% higher and 95% lower. We know the outlier values of a home price by looking at this residual graph. We also know the slope and this intercept value and this trend. Those are those terms: multiple R square, adjusted R square, and standard error. All are auto-generated. Only you have to know the significance of the value or how to explain that value. All right, so that's all from my side today. Now, if you have any question, you can turn on the camera.